Welcome to another lesson on all about AI. In this lesson, we are going to cover about data pre-processing. Data pre-processing is one of the most vital part of any machine learning project. So if we compare with our analogy with oil and car, all collected data is like crude oil. In crude oil, it first goes through refinery, and then this refined oil is being used for car, Formula 1 car, different kind of vehicles, aircraft. So all of them have different need in terms of purity or goodness of the oil. Similarly, when we see the data, we have collect raw data from various sources. Once this data is being collected, it has to go through various pre-processing to remove various problem in data to make it usable for the algorithm. Now, different algorithm has different need. Just like the Formula 1 car, the quality of oil and the normal car quality of oil differs. Similarly, some of the algorithm requires very sophisticated pre-processed data, while some algorithm they inherently come with data pre-processing and data manipulations. Now, we'll be covering various data pre-processing methods like data cleaning, data transformation, data encoding, data reduction, data scaling, data balancing, data discretization, data integration, data anonymization. Some of them will be specific to a few fields, like data augmentation will be used in image, text. Then there are specific pre-processing for text, image, and time series data. But even before we go into that details, we need to understand about the data. Basically, we need to know what we are going to pre-process or what we are going to correct. So first step is to examine various data types, its distribution, the basic underlying pattern in the data. So first step is to understand this data, which is done usually through a lot of exploration. This process is called EDA, Exploratory Data Analysis. Once the problems or potential issues are identified, then only we'll go into data pre-processing steps. So before we jump into understanding data, it's important that we understand various types of data. There are numeric data, which comes in two flavor, discrete and continuous. Number of student in class, number of car one would have, number of room in a house. All these are like discrete number. Continuous number like height of a person, which could be like 150.6 centimeter, temperature, which could be say 34 degrees centigrade or 102 degree Fahrenheit. Weight of a person, which could be say 60 kg. So all these are example of continuous data. Then we have very well-known data, binary data, which is only two possible values, either say 0 or 1, yes or no, on or off, good or bad, something like that. Then we have data for date. Now again, it comes in various formats, like it could be MMDD, YY, or it could be also with timestamps. So these are like various example of dates. There is another crucial category is categorical data. Categorical data comes in two flavors, nominal data and ordinal data. When data has no hierarchy or sequence or pattern, then it's a nominal data, like say gender, male, female, colors, red, green, blue. There is no order in the data. Types of animals, dog, cat, bird. But when this categorical data has some order, say ranking, first, second, third, educational levels, higher school, bachelor's, master's, customer satisfaction ratings, satisfied, neutral, dissatisfied, all these have order. So they are called ordinal data. Then we have text data. So text data, there are various forms of text data: emails, social media posts, news article, books, product reviews, legal documents, contracts. So there are various kinds of text data. Next, we have specific category of data like image data, photographs, medical images, satellite images, X-rays, MRIs, different kind of image data. Then we have time series data, like various stock exchange data, seasonal data, like companies' profit and loss happening over the years. Next, we have audio data. So various audio source, like even this YouTube video has audio data from music, conversation, presentation. So all these are audio data. Video data. Of course, YouTube is a great source of video, and there are a lot of video data available everywhere. So data from drone, various source of video data. Other than these, there are many other sources of data like geospatial data, the graph data, like social network has the graph data, sensor data, various sensor collecting temperature, like sensor data in cars, sensor data from IoT devices, biometric data like fingerprints, retina scan. So all these are biometric data. We have genomic data. Then 3D data. So as you can see, there are many different types of data, and the processing for all these are different, and some of them require sophisticated processing to convert them to the data that algorithm would like to have. Now we are familiar with all these data type. The next important thing that we should know about is the exploratory data analysis. This is the very first step. Once data is being collected, we need to go through the data and understand about the data, like some basic statistics of the data. We also use various graphical method to understand about the data, different charts. We'll be using Titanic dataset as a sample example to explain the basic concept around EDA. So we are loading Titanic dataset here, and then basic information check. So you see there are 891 entries, and we can see there are 177 entries missing for age. Cabin, a large number of elements are missing, and those are like missing value handling candidates. Usually we will do a lot of analysis of data to find out more about what it contains, what are the different values, how it behaves. So in this case, we'll do basic statistics and distribution. Some of the fields like age distribution, fair distribution, mostly histogram, count plot, those we'll be doing. Say this is the age distribution, fair distribution, survival count, passenger class distribution. So you can see the class, all these classes are not equally balanced. Port of embarkation, gender distribution. Then we will also do bivariate analysis, bar plot between various fields like sex and survive, and also like pair plot, correlation metrics between various data elements. So this is like a pair plot. Here you can see like how the data relation between two variables are depicted here. The correlation between various fields. Then survival agent count, like for survival rate by fair. So that's how typically the EDA is done at very basic level. There are a lot of sophisticated approach followed for vision, text, all those cases. There are many more ways to do it, and we'll cover them in very detail when we'll go through some of the data elements, particularly in our AI Advanced and AI Wizards lessons. Next step is fixing data issues. So at this stage, after exploratory data analysis, we have found out all the issues or things that we need to address as part of pre-processing. First, we'll start with data cleaning process. There are 4 key areas of handling data cleaning: handling missing values, removing duplicates, outlier handling, correcting inconsistencies. Now, handling missing values. How you handle missing values? One way is to impute missing values through statistical data like mean, median, mode. Another way could be to remove the row or column if there are excessive missing values. Third way could be use specific algorithms that handle missing values natively. As I mentioned earlier, some algorithm can handle some of the data deficiencies inherently. Next thing we need to do is removing duplicates. If there is any duplicate, we need to handle. Now, one way could be simply remove all, but one instance of the duplicate data is retained. Question is which one we should retain. Most of the times it could be the first one or the last one among the duplicates. For specific cases, one might have to use aggregating the duplicate data points. In very rare case, domain knowledge is used to keep specific duplicate data. Next step is outlier handling. So in our outlier handling, we will detect outliers using statistical methods like Z-score, IQ or interquartile range, or some kind of plot like box plot or scatter plot, etc. We may also use model like isolation forest, DBScan, one class SVM clustering, which help to find the outlier. There are few mechanisms like capping flooring method like winsorization. So this limits the extreme values in the data to reduce the effect of outlier. It basically replaces the extreme value with specified percentile value. There are also mechanisms like replacing outlier with substitution, such as a mean, median, or some predicted value based on other features. Now, it's very important to understand some kind of machine learning. The purpose of that machine learning algorithm is to detect outliers, like anomaly detection, fraud detection. In those cases, the objective of algorithm is to detect outlier. We are not talking about those algorithms here. We are talking about in normal data or data for a purpose where we are trying to do some prediction, and their data has some abnormality or outlier, could be because of various reasons. It could be data entry error or something malfunctioning, because of which, and if we don't fix it, it could skew the algorithm output. That's the whole purpose of handling outlier, and we'll go in detail in our advanced lesson. Next thing is to correcting inconsistencies. There could be inconsistency in various ways, like dates, address, phone numbers. They can have different formats across different datasets, or even if we are merging different datasets from different sources, they can have differences in terms of formats. Just like a simple one, date could have MMDDYY format in one dataset, or in one field. In another field, it could be DDMMYY. So we need to make all this data consistent. Also, it is required to implement rule check to validate the entries are legitimate entries. Say age. We know the age cannot be less than 0, or it cannot be, say, more than 120. So if something is beyond that, we should have a mechanism to fix it. String matching and fuzzy matching. In many cases, the data would sound similar, or people will be entering the data in a similar way. Just like, say, in the case of name, like New York could have a New York City. There could be abbreviation like NYC. So we need mechanism to bring them all together to make a standardized form. Also, some cases, industry specific and domain specific knowledge is required to correct inconsistencies. Say, in medical domain, correcting medical codes based on standard classifications. So if there is an error, you can correct it by classifying based on other data element. Now, These are the main ideas behind data cleaning and how it is being done. We'll be covering them with detailed Python code and different methods in our AI advanced lesson. Now, to summarize what we have covered in this lesson, we have started our understanding of data by first understanding various data types. We understood about exploratory data analysis, and then we started our pre-processing journey by understanding various basic methods used in data cleaning. Thanks for joining me and look forward to see you in next lesson.